Hello there. Let's look at a few more questions of electrolysis. So like I said, electrolysis, the pattern you have to learn, you write the balance half reaction of reduction, and then you use the Q is IT, right? So in this case, you have 2000 kilograms, and you convert to grams by dividing 1 kg is 1000 grams. Cancel the kg to kg. Look at the t given, 20 hours. 1 hour is 3600 seconds, so hour to hour cancels. So you get the seconds. So that's just to add into the formula, right? I, the current we are looking for. So I is not the same as electron, right? It's the opposite value and the direction. Now, copper 2 plus is plus 2 electrons is going to copper metal. That's the GR, the red cat, the reduction. That's what always where you get the metals, right? The 2 electrons are for the balance equations, right? So those things need to be there. The 2000 kilogram is actually for a copper slab industrially. That's how we make it. That's a 2000. And so 2000 times 1000, that's the gram. So we already got that one. That's copper. And now gram to mole is molar mass is 1 mole copper, and then 1 mole copper is 2 electron moles from the balance equation. 1 mole electron mole is 96,500, the constant, Faraday constant, right? Okay, now cancel all the units, gram to gram, copper mole to copper mole, mole E to mole E. You have only coulomb. So we're going to plug in the seconds below. Actually, you are dividing, because coulomb divided by second is the ampere. That's the current. That's why the seconds, we put it into a division at the end of all our calculation. You see that? That's really important. This is a rather unusual way, but that's how the best way to do it, right? So let's get the number. Yes, so you get this, 84426. That's the coulombs per second. That's amperage. So a lot of current. So to make copper, no wonder copper is expensive, right? Okay. Let's go to the other one. Oh, even more expensive. Gold 1 carat is actually 200 milligrams. So that you don't have to know, it should be given. And the current here used is 0.1 ampere. That means 0.1 coulombs over seconds. T, the time seconds we are looking for. We're going to get seconds, right? Now, so Q is IT again, but we can start with the 200 mgs, right? 200 milligram is 1000 milligram is 1 gram gold or anything, right? Now we have how many grams for the molar mass? It's that's for the moles. So the atomic mass of gold is 197, and that's grams per 1 mole of gold. 197 grams per 1 mole of gold, right? Now 1 mole of gold needs how many electron moles? Actually, we need this half reaction. Au3 plus 3 electrons goes to Au. That's how the gold is deposited on jewelries, right? So now, 3 e-mole we needed for this one, but 1 e-mole is 96,500, the Faraday constant. Now we can start canceling everything, right? Yeah, let's write the 0.1 coulomb is 1 second. So we can flip the coulomb, the current, as needed, right? Let's cancel. Milligram to milligram, gram to gram cancels, Au mole to Au mole, and electron mole to electron mole cancels, coulomb to coulomb cancels. You end with the seconds. So that's what we expected. Make sure units are correct, seconds, and plug and chug. You get yes, this many seconds. If you need hours, divided by 3600 over 1 hour, so you will get the hours, right? So it's roughly 0.8 hours. Okay, so the next question. How much of oxygen liters can be produced? So we need, let's see, that means you need the grams per mole, right? Or perhaps that's what the question normally, liter, grams, or moles, right? So we use KOH, and the time given 1 hour is 1 hour over 3600, directly 3600 seconds, and 10 amperes, 10 coulombs over second. That's how we write it. So let's look at a little bit of logic here. So we have DC power given into a some KOH electrolyte, just a little bit, and then liquid water, because pure water wouldn't do it, right? We expect oxidation to happen in the anode, the positive pole of the battery. That's important. So anode does the oxidation, and oxygen is in the oxidation. Remember that way. The balance equation you can copy, that is actually 4 hydroxides, gives you oxygen, 2 water, and 4 electrons. So that's for the balanced electron half cell. We need the electrons. That's the electron moles, right? 4 electrons in this one. So just notice, if you have to do hydrogens, it's twice the hydrogen for 4 electrons. 2H2, that's the ratio. Every 1 oxygen mole, you will get you 2 hydrogen moles, right? Okay, so that's just a different thing. Here we go with the time, 3600 seconds. We have 1 hour, which is 3600 seconds. Now 10 coulomb, you can write it as it is, because seconds to seconds should cancel. Now 96,500 coulomb is 1 e-mole. We need 4 e-moles for this balanced reaction. It will give you 1 oxygen mole. So 1 oxygen mole is actually at STP 22.4 liters. So seconds to second cancel. Coulomb to coulomb cancel, e-mole to e-mole cancel. Now mole oxygen to mole oxygen cancel. You left with liters of oxygen. Now let's plug in. So you can actually do simply, all the top levels are multiplied, all the bottom levels are divided, right? So you get 2.1 liters of oxygen. So that's that. So that's another style. Try to look at the pattern again, right? So from the beginning, most of the questions in those 2 videos, I followed almost a similar pattern, right? Recognize that. So we're going to do one more question. Yes, so this is another style. It's an unknown monovalent metal deposited, and cathode get this much. And unknown monovalent means first column metals, the sodium, potassium, lithium, cesium kind of things, right? And then you get the grams are given. So that means number of moles divided by molar mass is grams. So we know we're going to use that one. So 9.5 amperes, that's the current I, 9.5 coulombs over second, and the T is given 90 minutes. 90 minutes is 1 minute is 60 seconds, so you're going to get 1800 seconds, 90 times 60, right? So let's see what we get here. So I is good, T is good, and then Q is going to be linked into the grams. Basically, if you know the grams, you're going to get the molar mass or the moles, right? So that's how we can go. So we can actually find the moles, the molar mass, the grams, the T, the I, or C, right? Any of these could be unknown. So first thing, like I said, half reaction should be M plus 1 electron. The red cat should give you the metal, right? That metal could be alkali metals, right? In this case, monovalent. Divalent is their alkaline earth metals, if the question is about divalent, right? Now, so let's put this one, 90 times 60 seconds and 9.5 coulomb over seconds. And again, 96,501 Faraday is 1 electron mole. In this reaction, 1 electron needed for 1 mole of metal. Now we are looking for the grams, let's say X grams, right? So that's what the X grams, that should be divided by the molar mass, right? We can just say X grams. So let's see. So we should be given actually because if you're looking for the molar mass, we can't have 2 unknowns there. Okay, that, yeah, she forgot to type that one. So let's put the value here. So yeah, let's get the units. So seconds over seconds, coulomb over coulomb cancel coulomb, e-mole cancel to e-mole, and big M we are looking for, we don't have it, but we have the grams of 12.54. So now the X and 12.54 we can resolve for the X, right? So that would be X is 23.61. The closest one you can find out, look in the periodic table between 20 and 25. Most close one is 22.5, which is sodium. So the metal has to be sodium then, right? Okay, thank you.